Hi class, welcome to Is451. I am Professor Jalani. Today we be covering the internet for chapter 10, which we are quite familiar with it. So let's take a look at the history. So the internet started somewhere in 1960s. It's to be more precise, is 1957. This is basically during the Cold War between USSR and United States, and the ARPANET or Advanced Research Project Agency was set up soon after USSR launched their first Sputnik satellite in space. So in 1962, there was a research program by MIT led by John Dick Leader and Leonard Kleinrock published a paper for packet switch theory. And there, the wide area network was created in 1965, followed by 1967, where it ended up with RAN, and with four computers from UCLA, UCSB, Utah, and SRI in 1969. Soon, there were 23 computers and 15 nodes in 1971 was created. And in 1972, ARPANET went public. And 75% of the email was via ARPANET in 1973. TCP/IP was then used in 74, where then followed by Telnet, MEFNet, HAPNet, SPAN, Usenet, BitNet, CSNet, Computer Science Network, UNet to EARN, or that's the European version of BitNet. It was quite chaotic because different country, different organization, different types of network. That was from the period of 1774 to 1982. And in 1982, that was where TCP/IP was the universal standard for all communication. And the internet was expanded through physical means, for example, from dial-up to fiber. And in 1984, DNS was introduced, which is a domain name server, where you buy your domain name in 1984. And from there, we have educational institution from Joint Academy Network, US National Science Foundation contributed to the internet. From 1984, there were 1,000 to all the way to 300,000 in 1990. And also it has went to commercial use. The concept was created in 1989, WWW, World Wide Web, by Tim Berners, and Mosaic X was created by the National Center for Supercomputing. So in 1994, there were 3.2 million hosts with 3,000 websites, and spreading to 2001 with 11 million hosts and 30 million websites. And today we have World Wide Web 3. Okay. So as we progress, World Wide Web 4, WW4, 1994, we have Hotmail, Java, ICQ chat, and 1998 Google was founded. And today it has grown exponentially. According to the richest man in the world, I think you all should know, Jeff Bezos, his research has mentioned that the internet is growing at 3,000 times, and that's why he quitted his job to create Amazon.com. Okay, having said that, let's move on. We talk about internet protocol, TCP/IP, ARP, and DHCP, and NET. Take a look at it. For IP, as we can recall, the highest level, things like email, transport layer, as we can see here, 4 layers. Over here we see the progression of the network from application layer, transport network, interface layer, and basically to the router and to the web. As the data progresses, more packets are being introduced, either from the start or to the end. Basically, there's several versions. Version 4, which is currently used, and followed by version 6. Let's take a look at version 4. Here we have, on the diagram, we have the breakdown of the frame, where they are segmented from version to helm, service, total length, identification, flags, fragment offset, time, protocol, header, checksum, IP address, destination, IP option, padding, and the data itself. IP4 is perform offset and more field, okay, where there is 8 layers. Here we example for 32-bit binary. So we have 32 bits, or we can translate into dot decimal. That's the IP address. There are some website, if you know the IP address, you can key in this number and you can straight away get a website. We have different classes here, A to E. So as the internet grow, the IP increase, internet protocol. Again, class A to D, okay. Subnet range masking. Right. Here we have example of 2 class C. A company could contact an ISP which would lease 500 IP addresses to a company. Companies like GoDaddy, GetterHost, that's where some example companies that you can get. Some IP address are indicated with slash notation. In this case, slash 27, sorry. So here's another example. This is basically how it's being masked, okay, and you get the result. Let's take a look at IP6 or IP version 6. As the number says, there's increase in bits, 128 bits. Here we see the binary is being converted to hexa. Okay. So in TCP/IP, technically there's a checksum and urgent pointer where the port number identifies a particular application, okay, for a particular device. Right. As illustrated in the diagram here. Next, we have Internet Control Messaging Protocol, or ICMP. Most commonly used in nodes and router, and it performs IP error reporting. Also, we have the datagram for user, right, or UDP. Here we have the multi-protocol label switching. It's an additional layer for TCP/IP. Okay. Here you see the first and second label, where there's additional on top of the header and the application layer. So the question is, if the packet has traversed the internet and counter destination LAN, how does the packet find destination workstation? So in this case, the LAN doesn't use the IP address, use the MAC layer address. Okay. This is for ARP specifically. Next we have DHCP. It's more assigned to a workstation. It looks at the static table. So if there's nil, they will go to the available pool. Followed by NAT, or network address translation, where most of the traffic leaving are also originated with global IP address and also with coming address. Here the example we have 10.0.0.0 and to 19.168.22.255.255. These are basically a block for private address. So when there is a send package, it's changed into a cache, stored in a cache. In the event of VPN, protocols technically it's not secure. So in the event they want to access office or corporate network, there must be a tunneling. It usually works that the user from the outside of the company has to create or establish a legitimate connectivity prior connecting to their network, or remote access, for example. Next we go to the World Wide Web, which is very common to all of us. It's created by HTML, hypertext markup language. Is basically the basic programming language if you look at the source code from any web pages. Protocol hypertext transport protocol, HTTP, which you sometimes usually type prior to the website name. So in locating the website, here we have diagram. Here shows URL with the service type, the host, domain name, directory, subdirectory, and file name. 1, 2, 3, and 4. Okay. Here we have the what does the internet do when somebody types in a web address. So like we mentioned in the diagram just now, we go to the domain name, local server, the root, step by step. As for internet services, we have the email, file transfer protocol, remote login, mentioned earlier, voice over IP, list server, streaming audio and video, instant messaging, tweets and blogs. I believe there's more of this as we speak. Email, we all commonly know using the email, meme or multi-purpose internet mail extension used to send attachment. Okay. To send email, we have SMTP, a small simple mail transfer protocol, and POP3 is used to hold and retrieve together with IMAP, okay, internet message protocol. To send file over, we use FTP, file transfer protocol. You can send big files over via this system, and most URL are beginning with FTP. In fact, there are some free website you can use, sendbigfile, transferbigfile.com online. Next, we take a look at remote login. Like I mentioned earlier, you could access your office computer from anywhere. It could be TeamViewer, it could be Microsoft accessing the computer. Right? And prior to that, you need to have a username and password to establish authentication in order to log into your system. Voice over IP. These are basically PC to PC. It could be Skype, it could be Zoom. Here they mentioned the earlier network, 64 kilobits, okay, are able to transmit, but not as clear as today. The H.323 is basically created in 1996, okay, followed by SIP, Season Initial Protocol. It's a basically standard. Take a look at this voice over IP example. Here you see the telephone number is converted to this digit in ARP. Also, we have the list server. These are basically popular to create and manage internet mailing. Next, we have stream audio and video, right, or RTP, real-time protocol, and real-time streaming protocol. It could be used in Instagram, for example, live story or live, or even in YouTube live feed, right? As for instant messaging, tweets, blogs, character are 140, which is quite common. We see the US president using that. Blogs online. Next, we have in business, we have e-commerce, which is a booming market, and we have all the most richest men with this category of business, technology. We have e-retailing, EDI, electronic data interchange, micro-marketing, internet security. These are the major player. Next, we have cookies. So this is basically created in your hard disk. Is to track the activity. Apparently, it's an invasion of privacy where some data could be tagged. Intranet and extranet, which are commonly practiced in internal use of a company or organization or office, where there is security for the network. As for the future, so we have various improvement, IP, fax, extension FTP, common name, and distribution of version, and more advancement. So, and most of this technology is being set up as the demand of users increase. It could be digital library, virtual laboratories, telemachine. Today, especially with the pandemic, every institution, every corporation are going online or working from home. Here we have, for example, a company creates a VPN, 3,500 remote site. Here the system dials 1-800 number phone system and connected by the PABX into the modem. So instead of using the internet, okay, to keep cost low, we dial into the phone line, and from there they can be connected to VPN to be routed into the corporate office. So that's pretty much it for the internet. Please feel free to email me if you have any question, or drop by my office. Alright, thank you very much. Please stay safe. Bye bye.